Hey guys, and welcome back to another video, and today we will be talking about some basic definitions, and that will lead to an introduction to the pH system, which is acidity, basis, like first basics. Oh, all right, so let's start with our basic definitions. Here, let me just move some things out of the way so this is easier to put down flat. All right, first we have to understand two very important terms, hydrophilic and hydrophobic. This is how you spell it, hydrophilic, yes, versus hydrophobic. Can you guys guess what these mean? So we have hydro, which means water, and then in this part we have phobic, and if you know, if you have a phobia, it means you're scared of water. And philic is loving water, water loving. Okay. And so let me give some more background on that. Hydrophilic substances is any substance that has an affinity or love for water. And these are typically ionic or polar bonded molecules. Okay. Most of these are able to dissolve in water. However, when the molecules are too big, they don't dissolve. For example, cotton. So we know cotton is hydrophilic because of cellulose. Which is the main content. And cellulose in cotton has a lot of polar covalent bonds. The problem for this is that cellulose is a macromolecule. It's very big molecule. Okay? And it's too big. It's giant. So it's too big to be able to dissolve in water. So instead, the water in hydrophilic molecules, they form hydrogen bonds with each other, which is very funny. So if you think about it, this is how you're able to dry with cotton towels. Because water loves it, and so it forms hydrogen bonds and it sticks to it. All right, and now let's go over hydrophobic. Let me just draw a quick line so you guys can see. I think that's good for a line, yeah. Okay. So hydrophobic is a substance that is scared or has no affinity for water. Okay? And typically, well, all the time, they're non-ionic and non-polar. And what this means is that there's not going to be regions with partial or full charges, and so water doesn't form hydrogen bonds with these. So one very famous, or I guess like cliche example is oil, right? Like if you put it inside of a cup of water, it's not gonna dissolve and it's not gonna form bonds. It's just gonna like be like that. And this is because oil has carbon hydrogen bonds, which are equal in electron sharing. So it's going to be carbon-carbon, carbon-carbon, and which is equal in electron sharing. And this is a good reason, like due to their hydrophobic qualities, it's very good for cell membranes. Yes. All right. So now that we have these basic things defined, let's take a look at the pH system. So sometimes, right, a hydrogen atom that is inside of a hydrogen bond with two water molecules can shift from one molecule to the other. So basically, what that results in is a hydrogen ion and a hydroxide ion. So hydrogen ions are formed when the hydrogen escapes. So it's a single hydrogen. And this is what's left, like what the hydrogen leaves. This is the OH, right? Oxygen and hydrogen. And the water molecule that has the extra hydrogen will then be called H3O plus, or a hydronium ion. And you'll see why this is so important later. Because of these changes in water, it leads to a pH system and changes in pH. So the pH system is typically denoted as pH level 1 to pH level 14, in which at equilibrium we have pH of 7 in the middle. And what that means is that during equilibrium, the concentration of H plus and OH is at 10 to the 7th M, which is in 25 degrees Celsius. And basically, during equilibrium, concentration of actual water molecules is much, much greater than that of the H plus and OH ions. And so the pH scale and basically the concentration and differences of hydroxide ions and hydrogen ions dictates what pH you're at, as we saw. Like a pH of 7 would mean 10 to the 7 M for OH and H plus. And so pH scale, what this describes is how acidic is it? How acidic environment, basically. All right, and so we know that organisms are going to be very sensitive to the changes in pH because, well, I'm not gonna lie, I wouldn't want to live in acid all my life. But that is a story for another time, and that is it for today, guys. I'll see you guys all next time. Bye!